During World War II, shortages defined daily life. Steel, rubber, fuel, and even basic protection were in short supply. Yet, in the middle of this scarcity, wartime engineers discovered something unexpected. A way to strengthen wood using nothing more than a special chemical coating. It was not new armor. It was not a secret metal alloy. It was paint. In this episode of Survival Archives, we explore a little-known World War II innovation, a chemical wood treatment that helped reduce splintering, absorb impact, and improve protection when steel was unavailable. By the early 1940s, armor plating was prioritized for tanks, ships, and aircraft. Field engineers were often left with whatever materials were available. In many theaters of war, especially in the Pacific and North Africa, that material was wood. Wooden trucks, crates, guard posts, boats, and supply structures were widely used. But untreated wood shattered dangerously when struck by bullets or shrapnel. This created a serious problem. How could soldiers protect themselves when proper armor was impossible to obtain? To solve this, Allied researchers began experimenting with ways to strengthen wood chemically rather than mechanically. At the U.S. Forest Products Laboratory in Madison, Wisconsin, scientists tested compounds that could penetrate wood fibers and harden them from within. One promising substance was sodium silicate, often called water glass. When combined with casein-based binders and applied as a coating, it soaked deep into the grain of the wood. Once dry, it formed a dense, mineral-like structure inside the material. The chemistry was simple but effective. Sodium silicate filled the pores of the wood and reacted with air over time, creating a hardened, silica-rich layer. This reduced splintering, increased impact resistance, and improved fire resistance. The coating did not make wood invulnerable. It could not stop heavy rounds or armor-piercing fire. But tests showed that treated wood performed far better than untreated boards. Small caliber rounds were slowed, deflected, or caused far less fragmentation. In practical terms, this meant fewer injuries from flying splinters and better protection behind improvised cover. Engineers applied these coatings to guard posts, ammunition crates, transport vehicles, and wooden structures near the front lines. Multiple coats were often used. Each layer increased density and durability. In humid regions, such as Burma and the Philippines, the treatment provided additional benefits. It reduced moisture damage, insect infestation, and fire risk. For soldiers working with limited tools and materials, this chemical treatment turned ordinary wood into a far more reliable defensive material. The process required no factories. Sodium silicate was mixed with standard paint or varnish and applied with brushes or sprayers. After each coat dried, another layer was added. In some cases, warmth from sunlight or field stoves helped the compound penetrate deeper. Once cured, the surface became noticeably harder and more durable, closer to stone than timber. This innovation was not about perfection. It was about adaptation. When steel was unavailable, chemistry provided an alternative. When resources ran out, ingenuity filled the gap. The goal was never to make wood truly bulletproof. It was to reduce risk, slow threats, and keep soldiers alive with what they had. Today, sodium silicate is still available under names like water glass or silicate sealer. While it is no substitute for modern armor, the principle remains useful. Chemical reinforcement can improve durability, fire resistance, and moisture protection for wooden structures. For historians, builders, and survival-minded individuals, this technique remains a living example of wartime problem-solving. This idea also influenced later developments in composite materials and protective coatings. The concept of strengthening organic materials without heavy machinery was decades ahead of its time. It reminds us that many important wartime innovations were not dramatic weapons, but quiet solutions built from necessity. The story of chemical wood reinforcement reflects the true spirit of World War II survival. When steel ran out, engineers turned to chemistry. When resources disappeared, creativity took over. Sometimes history's most effective solutions hide in the simplest forms, even in something as ordinary as paint. This has been Survival Archives, documenting how people adapted when survival truly mattered.